Our brain is made of billions of nerve cells, and they're all connected. If we take a closer look, a nerve cell seems to have antennas. Most of them are receivers of information, but only one is a transmitter, called the axon. This axon is connected to several receivers of other cells, forming a gigantic neural network, the brain. Meet John. John is a kinesin, a motor protein. He lives inside a nerve cell, and he has a proper job. To ensure that a brain cell does his job properly, it needs the continuous flow of building materials, proteins. They travel through the cell using the cytoskeleton. If you would compare a nerve cell with a city, the cytoskeleton inside the cell would be the roads, and the traveling proteins would be the traffic. These materials are towed by motors along the roads. And just as in real life, there are different kinds of motors and different kinds of roads. John's sole purpose in life is to deliver his cargo to a specific place in the axon. He takes the main roads, and he walks in just one direction only. John's job may seem easy, but it's not. He has to overcome a number of obstacles to ensure that the right amount of cargo arrives at the right place. To make the journey even more difficult, John is not alone. Other motor proteins ride along with his cargo. They haven't woken up yet, but that will happen soon. The journey starts in the center of the city, just like in the center of the cell. To enter the axon, John has to pass a place called the axon initial segment. In this segment, there are two kinds of roads. The main roads that John uses, called the microtubules, and a lot of little alleys called actin. And here, our brave motor protein meets his first challenge, because one of his sleeping travel companions, myosin, has woken up and starts to cling to the actin. And there are a lot of alleys. Only brute force can save John now. Fate strikes again. The other companion, Dynin, wakes up, and he can only walk in the opposite direction of John, resulting in a tug of war. But there can be only one. Along the axon in which John travels, there are places called synapses. Here, the axon connects to receivers of the other cells. Regulating proteins call the shots here. This traffic police makes sure that all passing traffic gets to the right destination. If John's cargo is needed in this synapse, he will be stopped and myosins take over his load. But today, John's cargo is safe. But what he does not know, that his road is under construction just a few blocks away. In our nerve cells, the cytoskeleton is changing constantly. Roads are built, but are also broken down. Facing this kind of obstruction, John has to find a detour. John isn't the only motor protein on the road. There are many more. Our nerve cells need a smooth traffic flow in order to perform well. A traffic jam due to problems during the journey may ultimately result in brain disease. Understanding the challenges John faces could improve treatment or prevention. Finally, John arrives at his destination. He has fulfilled his destiny. But several other Johns are just getting started.
بقى قلنا الاثنين في الساينس كده. المايند والبيجنين دي بتخش